Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 9th, 2025, about 6 days ago. It shows that a robot policy trained only on human demonstrations from a tactile glove can carry out a difficult wiping task, with the tactile-aware policy reaching about 72% success and clearly beating vision-only baselines. The paper is titled OSMO, Open Source Tactile Glove for Human-to-Robot Skill Transfer. And as we will see later, the implications for teaching robots through human touch are pretty exciting. Alright, Figure 1 introduces the core idea visually, showing how the tactile glove becomes a bridge from human demonstrations to robot skills. The top panel depicts the OSMO glove with blue patches, marking the 3-axis tactile sensors spread across the hand. To the right, a checklist highlights full hand tactile coverage in the wild hand tracking, captured human dexterity, and robot deployability. The bottom row contrasts a human wiping, with the glove on the left, and a robot reproducing the same wiping motion on the right, with no robot training data required. So while Figure 1 highlighted the concept, Figure 2 shows how the same tactile glove works across many real-world tracking setups. The top row demonstrates the glove under different cameras and headsets, with hand skeleton overlays that show native hand pose tracking still functioning. The bottom panel presents the glove integrated with a commercial Manus tracking glove, where blue pads mark magnetic skins that add touch sensing without disturbing motion capture. Alright, the previous figure emphasized how the glove integrates visually. Figure 3 now gets into the electronics that make the sensing work. The main diagram in the center shows a hand-shaped microcontroller board that gathers data from every fingertip sensor and sends it out over a USB-C port. On the left, a zoomed-in set highlights each tactile sensor board, which carries 2 magnetometers and shared power and data lines. This wiring layout supports 12 3-axis sensors, while keeping the system compact and robust for real-world use. So, after Figure 3 detailed the electronics, Table 1 reports how well different magnetometer setups suppress magnetic crosstalk noise. The rows show that the shielded dual magnetometer design cuts average noise roughly in half compared with a single unshielded magnetometer both for finger motion and for adjacent contact tests. In the top half, during finger waving, noise at the thumb and middle sensors drops from well over 100 microtesla to around 70 and 30 microtesla. In the lower half, when a nearby finger is pressed, the same shielded configuration again yields the lowest noise, which means cleaner tactile signals for the learning algorithm. Well, the previous table focused on sensor quality, and Figure 6 now walks through how raw demonstrations become training data. The top panels show synchronized tactile signals and 3 camera views of a human wiping the board. The middle row illustrates hand estimation, where language-grounded segmentation, tracked key points, and depth refinement recover the glove pose in 3D space. The next panels depict inverse kinematics retargeting that maps the human hand to the Franca arm and ability hand joints. The bottom row summarizes the final policy dataset, which combines images, tactile glove readings, and retargeted joint commands for learning. Okay, while Figure 6 traced the data pipeline, Table 2 reports how that translates into real task performance. The table compares 3 sensing setups for the wiping policy across 12 trials. Using only proprioception, success sits around 27% with large variability. Adding vision nearly doubles performance to about 56%. Adding the tactile glove on top of vision and proprioception lifts success further to roughly 72%, which shows that direct touch feedback materially improves reliable wiping. So the big message is that a relatively simple, open glove that senses touch in 3 dimensions lets robots learn contact-rich skills straight from human demonstrations, with no robot data needed. This points toward more natural teaching by touch for many everyday tasks. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.